Hi, folks. Jonathan Amsterdam from the Go team at Google. It's my third year in a row in Berlin. Very excited to be back. This talk is for anyone who's ever written an API. I want to talk about how dealing with change, because your API is going to change. Your beautiful, perfect API will definitely change. Change is inevitable. So how can you change it while minimizing disruption? Disruption to you as a maintainer, but also, more importantly, disruption to your users. So for the most part, we're going to talk about breaking changes, changes that cause your users to have to do work. And there's a lot of forces on your API making it change. People want new features, and actually that's the easy part because it usually just means adding things. There's also bug fixes that you have to do. You might want to try an experiment. Experiments are, adding the experiment is not the breaking change, but removing it when you realize it's not right, or changing it when you realize it's not quite the right API, that's a breaking change. And then there's forces acting internally, like you've made a mistake or you want to do something better, you found a more general way of doing things. And then there's the problem where you're wrapping an existing API or you're implementing a spec, and changes to that underlying thing force changes on your API. So we'll talk, again, why breaking is a bad thing. We'll talk about how to anticipate breakage and future-proof your API so you never have to deal with it. And then when there's actually a potential breaking change, how to avoid the actual breakage. And last, I want to talk about experiments. So breaking is bad. First of all, some kind of breaking is not bad. If you're fixing a bug or a security problem, yes, in a sense you're breaking your users, but what you're really doing is improving their code. So that's not necessarily bad, unless, of course, the bug is so old that people have come to depend on it as regular behavior. And then it falls into the second category, where so everything else is either very bad or somewhat bad. The very bad case is when you keep the same import path and you make a breaking change. So you go from v1.2 to v1.3, same import path. It's a minor version bump. And now users have to choose whether to stay on the old version and not get the new features, or whether to incur the toil of moving to the new version. And sometimes they don't really have that choice, because when you use a minimal version selection, well, first of all, let me say that your module might be the most important thing to you, but your users might depend on 100 modules. And if everybody caused a breaking change, they'd have nothing to do but fix those changes, and they wouldn't be able to get any work done. And any change to any of those that upgrades your version can also upgrade the end user's version. That's how minimal version selection works. So you cause your users toil, they get angry at you, they lose trust in you, and eventually they abandon you. Yay! Now you can make all the breaking changes you want. The less bad case is when you go to a new import path, and as you probably know, there's tooling support for a particular new import path when you move to v2, or in general, from vn to vn+1. Users still have to choose whether to follow you along, but at least no one else is going to force them to upgrade. And one problem with that, though, is how will they know about the new version? Package site will say there's a newer major version, but maybe they don't go to package site for your package, because, again, that's one of 100 dependencies they have. Also, for you now, there's a maintenance burden because you have to maintain v1, possibly forever, as well as v2. So still bad, just not as bad. So let's see how you can avoid breakage. We'll start by talking about ways you can preemptively anticipate breaking changes and avoid them. And the most important rule here is to be minimal. You can always add stuff. It's much harder to change or remove stuff. So don't use an exported symbol if an unexported one will do. If you have some sort of convenience function you think people might like, wait till they actually ask for it. Don't provide it yet. Provide it unexported maybe for your own internal use, but don't export it. If you have to export something because it's used by multiple packages in your module, put it in an internal package. That way it can be exported and used within that tree, but not outside. Did you know that the net HTTP tree has 4 internal packages, and the crypto tree in the standard library has 58 internal packages? No, you didn't, because you've never had to use those directly. Now I want to talk about options. If there's some large chunk of behavior, like you're creating a new complicated instance of a type, like a printer, or there's some complicated thing like parsing HTML, you can probably anticipate that users will want to configure that. And maybe you just know there's one or two ways to configure it, and then you can just add regular arguments. But usually there's sort of an undefined number of possible additions. And you might want to future-proof by using options. And there's 3 ways to do that. One way is to just add exported fields or exported methods to the type. That doesn't work if there's a function like parse, but it works if you're creating a new type. And the best thing about this way is you can always do this after the fact. But it's not great because users aren't sure if they can have to set this thing before first use or if they can set it in the middle. So there's a sort of a sharp edge to that API. So I don't love that style. You can use option structs, where you define a type that's a struct that has all the options that the user might want. And you usually pass it by pointers so that they can just pass nil. It's easy to write nil. That gives them the default behavior. And also you want the 0 value of that struct to be the default behavior. And that's pretty easy to use. It's very clear that you can only set those options at creation time. And the problem is that what happens when you have non-zero defaults? So the answer there is you use a pointer, as I was saying at the Ask a Go team event before. If you use a pointer to an int and they don't supply it, its value is nil, and that means the default. And the hard thing there is creating pointers to constants, as Dave Cheney talked about before, and there's a lot of packages to do that. And hopefully, in Go 126, we'll have a solution to that. There's an issue there. A lot of people internally like it. It's got 500 upvotes. Maybe we could give it another couple of hundred upvotes. What do you think? So read it. That's the QR code that links to it. If you like it, upvote it, and we'll try to get that in. It makes it very easy to create a pointer to an integer or a string or whatever. What I do to avoid another problem, so another problem is that someone might modify that struct after they passed it in, which is sort of a weird thing to do, but someone might do it. So I usually copy it. And I do it like this. Inside the type, I declare a variable that's of that options type, and I just copy it if it's not nil. That makes a shallow copy. If the options are slices or maps or something, you have to do a deeper copy. But that prevents your type from depending on anything that the user does. Another common option technique, variadic functions. This is very popular. It's where you use a variadic argument, and the option type is maybe an interface or maybe just a function that will modify some state. And now each option is a function that returns that type. And this works really well for the 0 value problem, because if you don't supply the option, obviously you're not providing it. It's the default is clear. But it has other problems, like what does it mean if you pass the same thing twice? Or if you pass the same option twice, but with different arguments to that option function. So it also has its own problems. And I just find it a little heavyweight, like you have to define a function for every option instead of a field, which seems lighter weight to me. So I tend to prefer the struct field. But the point is, all 3 of these techniques future-proof that piece of code, that constructor or that function, against breaking changes in the future. Let's talk about future-proofing interfaces. You can't add a method to an interface without breaking users, at least if the interface has only exported methods. So here we have an interface with the method A, and in box 2, someone defines a struct that implements A, as you can tell from the third line. Sorry, implements I by providing the method A. And then we add method B to the struct in box 3. And the same code, 2 and 4 have the same code, but 4 breaks now because T doesn't implement B. So you can't add a method to an interface and preserve backwards compatibility. But if you have an interface that you only use for your internal use, you don't want other people to implement it, you can provide an unexported method. Now they can't implement it directly. And this is, in fact, a real interface. It's the same interface implemented by testing.t, testing.b, and testing.f. So those are the only types that really need to implement this interface. So we add that unexported method to it, and now we can add more exported methods to it. As a case study, let me talk about something that I and a few other people on the Go team have been working on pretty intensively for the past month or so, and that's our SDK for the model context protocol. Now, in the pink, you see what the spec says. So this is a case, in one of my early slides, I showed changes from below. This is a case of that. So our API, our Go API, is sort of wrapping or implementing a spec. And we want to be sensitive to changes in that spec. So the spec says, call tools a function from call tool params to call tool result. And a call tool param consists of names and arguments. So originally, we thought, let's make it easy for callers and spread those two arguments out as regular arguments to call tool. But the problem here is that the spec can backwards compatibly add more fields to that call tool params thing, and then we'd be in trouble. We'd have to make some sort of breaking change or use some other technique. So then for a while we thought, well, let's still keep the nice first two arguments, and we'll just put everything else into an option struct. So we thought about using the option struct pattern. And then finally we said, let's just keep everything consistent and have a call tool param struct that mirrors the spec. It's just simpler, and it's really not so painful to write that struct literal. Now, these future-proofing techniques, you have to be judicious about them. If you just add them everywhere, you'll end up with a lot of clutter. Not everything needs this, and you have to use your judgment. You have to use prior art. Sometimes it's very nice not to be first to market. You can see what other people have done and where things are going. Listen to early users and find out what you think is going to change and what you think is going to require options. Well, finally, the day has come when you really do have to make a change. You didn't future-proof this particular part of the API. So let me talk about 4 ways to deal with that. First, if you're lucky, the change happened while you're still at v0. Launch at v0, which means there's no stability guarantees, and iterate with some early users until you get some API that you think is fairly stable. But don't stay too long. This is a mistake a lot of things make, a lot of packages and modules make. If you stay at v0 too long, remember 0, 1, they're just numbers. People matter. And if people see that things something's been at v0 for a long time, for years, they're just going to either assume it's stable, or some projects and companies won't use anything at v0 because they'll assume it could break and they want to wait for it to become stable. Either way, you'll either have users who ultimately get broken and stop trusting you and stop using your code, or users who will never use your code in the first place. Another way to deal with breaking changes is just to control all uses of your package or module. And you can do that by making it internal, as we've said, because all uses are in that tree. You can do it if this is for a company and there's just a private repo somewhere or a collection of repos. Or, and this is not the best thing to do, but you may have to, you can just document that it's in fact something private. So this is an actual function also in the testing package called main start. I wish it was called internal main start or unstable main start, so the name gives you a big clue about what's going on. But at least we have documentation that says, hey, we might change this because it's really only for internal use. But sometimes you can't, even if you can theoretically control all uses, you can't, in fact, make an atomic change that both makes the breaking change and fixes all the users of that, because the repo's too big or for some other reason. So a great example of that is something that Mike Stapelberg, my Go team colleague, is going to talk about, I think, right after me, shortly after me, which is the Go protobuf. That project, which is not a breaking change, but it's sort of heading towards a change in the API, started in 2019, and it's still not quite done in 2024. So, or today, I think. So sometimes even if you know that there's a finite number of users, you can't get to them all atomically. If the breaking change is a behavior change, you could do what we do on the Go team and have some sort of environment variable and keep the old code around. As an example, what I talked about last year are these new patterns in the HTTP serve mux where you can use curly braces to create a variable for a segment of a URL path. And the problem with that is that's a breaking change because someone might have written a literal URL with braces. You shouldn't do that. Braces are not valid URL characters. But someone may have done it anyway, and we wanted to preserve that behavior. And the way we do it is we just have a complete copy of the old code in the repo there. And it's activated when you set this Go debug setting. So it's a maintenance burden for us but it's worth it to maintain backwards compatibility. And of course, when you do that, pick a different environment variable. Don't use go-debug. But otherwise, it's pretty easy. Your code just checks the value of the environment variable and goes back to the old code. Now, you can't do any of those things, and it really looks like you're going to have to break your users. And let's just take the case of adding an argument to a function. That's usually what the problem is. You can't add an argument to a function. That's clearly a breaking change. All your users' call sites will break. You also can't add a variadic argument. Some people think you can, but you can't, because the call sites will all work. But if anyone mentions the function signature anywhere, since you've changed the signature, code that uses that, like for an assignment or parameter passing, will not compile. So you add. Instead of changing, you add. You add a new function. In this case, we added position 4 to add a Boolean to that. And in Go, we always try to come up with some cute, clever name that kind of sounds like it might have been the original name all along. If it was Windows, we'd have X. We'd move file and move file X, and they do X for everything, which is, at least it's consistent. But we try to make with the cute names. Another example is around the same time context was coming around, and we had to add context arguments to everything, someone noticed that creating a database transaction also involves some options. So we had begin and then begin TX, which includes both the context and options. And by the way, that option struct originally just had two things, read-only, and I can't remember what the other one was, but there's just two options that came into play. And now it still has the same two options. So was that a bad design? No, it was the right choice at the time. We didn't know that there would never be more than two, and in fact, maybe it'll be a third someday. I showed you that HTML parse thing. We ended up, as one might have guessed, needing options to HTML parsing because it's such a complicated thing. And here we went with the variadic function pattern with parse options, and we gave it a new name, parse with options. Wished it could have been shorter, but that's the name. Better than a breaking change. How do you add something to an interface if you can't add methods to an interface? You write a new interface. So here, this response writer from the net HTTP package, we wanted to optionally allow some response writers to have this push behavior. So we added a pusher interface, and then we can use a dynamic check, a type assertion, to see if this response writer implements pusher, then call push. That usually works fine, not always, because in block 3 here, someone has wrapped that response writer in their own type, and now it doesn't implement pusher anymore. That push method is not visible. So when you do that, there's no solution to this except you have to be aware of, you have to bubble up any methods that underlying type might have. If the new thing is just better than the old one, and the old one is in fact broken in some way, then deprecate the old one. So here, when we moved the entire IO util package, when we sort of deprecated the whole package and removed some things to IO, we actually marked them as deprecated just with this simple comment that you see in bold there. And now package site shows that it's deprecated, so you can see that you really shouldn't be using it anymore. It'll be there forever. You always can use it. We'll never remove it, but at least people will gradually, incrementally move to the new version. And if you click on that show button, you can still get the full documentation for it. It's just highlighted to show that it's not the right thing. And now I'm excited to report new in Go 126. This go fix comment, which as you can tell is not exactly a comment, it's a directive because it starts //go:. And that directive allows you to actually inline code. So uses of read all in IO util will be replaced by uses of IO read because the implementation of IO util read all is just, sorry, I said read, it's IO read all. The implementation of IO util read all is just IO read all. Right? So if you inline this function, you get rid of IO util. And the code that does this will also rewrite your imports. So that if that was your last use of IO util, it will disappear from your imports in that file. And there's two ways to do this. If you use GoPlease, our language server, you will see a notation saying you could inline this, and then there'll be an action that actually lets you carry out the inlining. So you can do it incrementally as you edit your code. Or you can run this messy go run command to do it over your entire code base. Or in the next version of Go, will repurpose the old go fix command to do this for you. And these transformations are sound, meaning they are always correct. They will never break your code. They will never make mistakes. They will never hallucinate. Looking at you, AI. You can also do this to get to a new major version to simplify your maintenance burden, because if you can forward the old F in this case to the new F, and you can mark it as go fix inline, then first of all, that's kind of a way of advertising your new V2 because people will see it in their editor. And incrementally, things will move towards V2. Maybe you'll always have to keep V1, but if you're in some sort of limited finite code base, if you're within a company, even if that company has 100 repos, eventually you can hope that someday you can delete V1. Last but not least, experiments. I feel that people don't talk enough about experiments. Experiments let users try a new feature. And this is a feature that you may not think is going to pan out. Obviously, if you thought it was going to pan out, you would have just added it. But you're not sure, and it's not something that you can just, ask in a discussion. You really need to let it sit for a few months with users and see if it makes sense. Even if you know you want to do it, you might think the API is not right. Now, if the experiment just sits on top of your API, then you can just put it somewhere else. So we were able to do that with something I talked about 2 years ago, the slog package, the structured logging package in the standard library now. We were able to play with it in xexp, which is our repo for experiments. And there was just a couple of very minor things that we really needed our hooks into the standard library to do, so we just left those out. And people could play with the bulk of it for quite a while before we baked it into the standard library. Another idea you can try is this idea of these pre-release versions. So if you have v1.x dash anything, it doesn't have to be the word pre-release. Technically, in Semver, that's not a stable place, and you can make breaking changes until you get to v1.x. The problem with that, though, is that's linear. Once you get to v1.x, you have to resolve all the breakage and lock it in. So if you have an experiment that you want to go on for months, either that experiment's going to hold back features you want to release, or either way, the features are going to force the experiment to get resolved. So it's not a good match for long-running experiments. And the answer is to use build tags. So let me remind you what build tags are. They control whether the compiler will compile a file. If you put a build tag like this, go build Go 124 in Windows, at the top of a file, the Go compiler will only compile that file if you're on Go 124 or above and on Windows. Now, those build tags are set automatically for you. But you can also make up your own. So you can make up a build tag, and I recommend if you're doing experiments, don't use a general build tag like experiment, but make something that's specific to your module and to the particular experiment you're running. Again, it can be anything. And now that way, your users can pick and choose among different experiments and different modules. And there's a couple of ways users can turn on these experiments. They can use the tags. Flag tags means build tags here. You can pass that to any Go command. Or you can set this environment variable Go flags to that flag, and then get it in your environment for all your Go commands. And of course, we do something similar, not simpler, more complicated, but similar, with Go experiment. Go experiment's a little more than a build tag because it can also affect compiler behavior and stuff. But it's a similar idea. So a good example is what Damian Neal, another one of my coworkers, is going to be talking about tomorrow morning. This synctest package, we didn't know if synctest was crazy or brilliant. And I think Damian would agree with that assessment. Nobody knew. So we really let it bake for a while and let people try it out. And whether we include it or not, I will let Damian answer. But here's a clue. He flew in from San Francisco. Yeah, so that you set by Go experiment equals synctest. But what you may not know is every experiment has a build tag. So experiments are at least partially build tags. I mentioned two of the three Go team speakers. Michael Pratt had the opposite problem. He had to conform exactly to an API. He could do nothing about it because it's the built-in map API, but he came up with a new implementation, which is very interesting. So, future-proof whatever you can, but not too much. If you're a baker, you know time in the oven is critical. So don't let things bake too long or people will make assumptions about it. That's both staying at v0 and it's also experiments. There are cases where people relied on an experiment that was in there for 2 years and then the experiment got removed. That's partly the fault of people who relied on the experiment, but I think it's also the fault of the people who made that an experiment. Don't change things, add things. And if possible, deprecate the old thing and inline it. And lastly, use build tags for experiments. That's all I have. Thank you very much.